In the previous video, we covered the vFlash pool. In this video, we will cover the vSphere 6.x resource pool management. Specifically, we will look at the virtual machine and the resource pool default share values and the impact that they could possibly have on your environment. We will go into detail of configuring resource pools and managing them, and we will also look at backing up and restoring resource pools when DRS is turned off and then turned on back again. With that, we are going to move now to our lab. So we are back at the VMware vSphere web client, and we are at the packed publishing site 3 that has one cluster with one host. Now, before we jump too deep into resource pools, let's take a look at the fundamental difference between the resource settings for virtual machines and the resource settings for resource pools. So we're all familiar with the idea of shares, limits, and reservations. The key, though, is here in our discussion is to take a look at what it means to say normal for a virtual machine and to specify normal CPU shares for a resource pool. So since we have a virtual machine right here, let's right click on that and look at its resource settings. So we see that normal shares means a weight of 1000, and low shares for CPU for a virtual machine is 500, as we know, and of course for high it is 2000. So the highest is 2000 shares, and of course you can set a custom as well with this, but let's just look at low, normal, and high for now. So the low is 500, the normal is 1000, and the high is 2000. So the ratio is 2000, 1000, and 500. Now this is for a virtual machine. For a resource pool, let's look at what it means to have a normal share of CPU. So I go into the packed pub cluster, I right click on that, and I define a new resource pool. Now when I look at the CPU shares normal, it's 4000. Let's look at the low. It's 2000 here, while it was 500 for a virtual machine, and it's 8000 here. Let's cancel out of this and go back to our virtual machine and look at its resource settings for memory. When you look at memory, normal shares are 2560. Now the algorithm for this is that you get 10 shares per megabyte of configured RAM for normal memory shares. So the amount of configured RAM for this virtual machine is 256 megabytes. Let's just confirm that. Go back to the virtual machine, I edit settings this time, and we see that the memory correctly is 256 megabytes. So the idea behind this is to show you that there is a fundamental difference between resource pools that are defined at our cluster level, where the shares normal share value as an example for CPU is 4000 versus for a virtual machine which is 1000. And the same thing is for memory as well. The normal shares are 163,840 megabytes for memory here in a cluster level resource pool, and the memory shares we can take a look at one more time. It's really quick to do. I think you already know the answer to this. Let's right click on this and edit resource settings. The memory shares normal we just took a look at is 256. Now why is this important? It's important because it is best practice not to have resource pools and virtual machines at the same level. So for example, if you have a virtual machine with normal shares, it has a value of 1000. At the same level, if you have a resource pool with normal shares, that, as we saw before, has a value of 4000. Okay, so a virtual machine that's running in that resource pool will actually have 4000 shares available. So out of the total of 1000 plus 4000, which is 5000, that virtual machine that runs inside the resource pool actually gets 4/5 or 80% of the entire CPU resources, compared to the virtual machine outside the resource pool, which will get 1000 upon 5000, which is 20% of the CPU resources which are available. Now, of course, if in the resource pool we add more virtual machines, then obviously the percentage allocated to each one of them goes down. And it's really difficult to manage, because when you add many more virtual machines outside, for example, if you had 10 virtual machines at the same level as one resource pool, all with normal shares of CPU, right? So that would be 1000 shares for each virtual machine. So that'll be 10,000 shares. Inside the resource pool would be 4,000. So we'll have 14,000 shares overall available. And the machines that are outside, each one of them will get 1000 upon 14,000 of the CPU resources. Good practice again is to have resource pools at the highest level, have very few resource pools, maybe 3 or 4 at the most, and then within that you can have sub resource pools. And try and make it a good practice, maybe by actually putting virtual machines in folders, so that you're able to move things in and out very easily into resource pools. So with that understanding of the number of shares that are available by default at low, normal, and high settings for virtual machines and for resource pools, let's now move into the packed pub cluster. By right-clicking on this, we want to deploy a new resource pool, and this is how one would deploy a new resource pool. For the time being, I'm going to cancel out of this, and we go to the manage, and we look at vSphere DRS. Now, DRS, as you can see here, is turned on, and for our work here, DRS automation is fully automated, power management is automated, and so on. I'm going to edit this and actually turn off DRS. DRS is now turned off. Now, when I attempt to create a new resource pool, you see that it is grayed out. You cannot create a new resource pool if DRS is not turned on. It's easy enough to do. We can turn DRS on according to a schedule. When we click on Schedule DRS, you get the DRS settings that will be used with the automation level, in this case of fully automated, the migration threshold of in between basically, and the virtual machine automation, everything else is also in place. And I'm going to try and get the power management is automatic, and when I expand this, we get the expansion of the power management automation levels as well. So very clearly you can set very granular manner the various DRS settings for power management and for DRS automation, right? And you can then schedule it. So you can define a task, a description, and then you can configure a schedule. So you can say run the action now, run this after startup, or run it later, or set it up on a recurring schedule. So if you have a situation where you have understood your work patterns and your resource usage of your data center, you are then in a position to actually, if the answer is by changing the DRS settings, which is obviously quite complicated, you have the ability to set this up on a recurring schedule as well, and so that you're able to manage it accordingly. Usually this is not done, just as a matter of good practice in data center operations. Simplicity is best, and so the idea is to understand your workload and the resource usage, and then appropriately set DRS settings and let the cluster and the ESXi algorithms take care of the hard work for you. So we cancel out of this scheduling DRS, and we're going to make the DRS settings right here. We click on turn on vSphere DRS. As you know, the options are manual, partially automated, fully automated, and then you apply priority 1, priority 2, and priority 3 recommendations. And of course, it's priority 1 recommendation and priority 5 recommendations. Okay, and then in the middle is 1, 2, and 3 recommendations. So this is again an advanced course. I will not deal with the basics of DRS on in terms of power management, which we'll deal in a separate video in this section. You have similar options available as well, and we'll cover some of the advanced options also in a different video. So I'm just going to cancel out of this, and still turned off. So I'll make sure that is actually turned on. So I'll turn on vSphere DRS and I click OK. All right, vSphere DRS is now turned on. Now when I right click on the cluster, I'm able to deploy a new resource pool. So let's deploy a new resource pool. Let's call it HackedPub resource pool. And we'll let it have normal shares. We won't have any reservations. We'll leave everything exactly the same it is. Again, because this is an advanced course, I'm not going to go into what it means to check the expandable reservation type box and so on. I'm assuming that you're very familiar with this. So we're just going to create a new HackedPub resource pool, and I click on OK. And it'll go through its motions, and here we have the new HackedPub resource pool. Now this is obviously at the same level as the virtual machines, and obviously that's not a good thing. So I'm going to drag and drop virtual machines into this resource pool. So I drag and drop the replication server. Now interestingly enough, this is a solution, right? So you should not modify the virtual machine directly. Use the management console, the solution, to make changes. I think we all understand that. For replication, we use its management console. We don't go in and change virtual machine settings for appliances. So that's just a reminder that not to treat it as a normal virtual machine, but treat it as an appliance basically. And I'm going to go one by one and actually even move vCenter, which we are looking at right now, in there, and we'll move in the Ubuntu virtual machine there as well. Now when we expand that, we see that the resource pool now contains these 4 virtual machines. I click on resource pool, I go to summary. You see there are 4 VMs, out of which 2 are powered on. That's right, Ubuntu and vCenter. There are no child resource pools and so on. And of course, one can create child resource pools again like this. So if I right click on the HackedPub resource pool, I click on new resource pool, and we say HackedPub child pool. We just make this let me click on this, and there we go. Okay, now I'm going to simplify this, and essentially I'm going to delete the child pool, so that we are going to go back up to the main HackedPub resource pool. Refresh that, and we are back up again to the HackedPub resource pool, which is right here. Okay, now when I right click on the cluster, right, you see an option here which is called the restore resource pool tree. Now why is this? Let's just click on that, and it says changes in the available cluster resources or virtual machine resources reservations may cause the resource configuration of the newly restored resource pools to fail. Basically, it's what it is saying is that select a resource pool tree snapshot. So going backward in time, at some point in time, I must have created a resource pool tree snapshot. Well, how does that happen? So if I delete the resource pool, then all these are going to go back up at the same level, and they will all work as virtual machines, and the resource pool allocations and the share values and everything else like that will be exactly as they were configured for the virtual machine, which is perhaps not what you were actually looking for. So if we look to now delete the cluster, because remember, we could only set up those resource pools when we set up the cluster. If I click on that, okay, and I say I want to delete that cluster, it reminds us that deleting a cluster removes the hosts and virtual machines from the inventory, and we delete this cluster. So if I say yes, and we see that we have deleted all those virtual machines and hosts. And now we see that after re-adding the host back into this data center, because we don't have a cluster, we don't have a resource pool, so all these virtual machines are again basically working at the same level. So the point is, how does one keep a resource pool around even though you have to turn on DRS and turn off DRS? I did it the hard way by basically saying, well, how do you restore that cluster back, or the resource pools for that cluster back. Okay, so I went through the process of recreating the packed pub cluster and turning on DRS, and now of course we should be able to add a new resource pool. So let's add the new resource pool like we did before. Okay, we leave everything just the way it was, and now we have the packed pub resource pool that will be created after I refresh. So we have the packed pub resource pool here, and again with those 4 virtual machines, 4 of 4, powered on VMs are 2, as we were before I deleted that cluster. The point again being, if you remove the cluster, the resource pool basically goes away. It was very easy to put it back. Now, if you have a situation where for various reasons you need to turn off DRS, so if you go into this cluster and you go into settings, and DRS is now turned on, and if for some reason we need to turn off DRS by unchecking that box and clicking OK, you will get a message that you have chosen to disable DRS. Doing so removes all resource pools in the cluster. Do you want to save a snapshot of the resource pool tree, which can be used to restore it once DRS is enabled? So this gives us an opportunity to make sure that when we turn on DRS back again, we can restore back the same resource pool tree that was in place before in that cluster. So we'll take a snapshot of the resource pool tree by clicking on yes, and then it asks us to basically define a place where this would be. So on my desktop, I'll take packed pub cluster. I click on save, and that file has been created on my desktop. Now I can go ahead for this cluster and see that vSphere DRS is now turned off. Now when I go back in here again and I turn on vSphere DRS after maybe maintenance or whatever on my data center has been done, and I click on OK, I see that re-enabling DRS does not bring back that resource pool. So I go back into that cluster, and to restore the same resource pool of which we had taken that snapshot before turning off DRS, I now right click on that and I see an option which is restore the resource pool tree. I click on that and it says select the resource pool tree snapshot. Now in this case we did take a snapshot, so when I click on browse, I look at that file. Okay, here it is, packed pub cluster snapshot, and I click OK, and I click on refresh, and as you can see right here, the packed pub resource pool is back with the proper virtual machines under it. So when we look at the summary again, we get the 4 virtual machines with the 2 powered on virtual machines exactly like it was before we turned DRS off. So a tremendously handy feature. Resource pools are extremely critical to the operation of a well-run vSphere data center. So use resource pools. Don't use them at the same level as virtual machines. Define 3 or 4, maximum 5 resource pools according to your business requirements, and use them wisely. And use DRS. Use all the automated facilities that vSphere gives you. And distributed power management is also one of them, which we'll look at very shortly. But a policy-based data center, which is what the vSphere or VMware software-defined data center actually is. You define a set of policies and let the software take care of things. Just like here, you define a policy where you define a packed pub resource pool, you define the constraints of that resource pool, and then you specify the virtual machines that run in that resource pool. Again, this is policy based, and then let the vSphere vCenter environment take care of things for you. Having looked at vSphere 6.x resource pool management, in the next video we will look at vSphere 6 distributed power management in great detail. I look forward to seeing you there.